my talk is not about Python. Surprise. I'm not going to talk about visualization libraries, that kind of thing, that are not that important. And this is not a visualization cookbook. You're not gonna get recipes from here to easily apply to your projects. That's not the point of this talk. It's a different thing. And I want to start talking about this graph. Anyone knows, just seeing this, what this is trying to communicate? What concept, what problem we are having nowadays? No one? No one? Climate change. You got a sticker. This is global warming evolution for the last 150 years. And this is the kind of thing I want to talk today. This is super powerful. This is super simple. There are no scales, no axes, no legends, no title. It's just colors. And it communicates what it has to communicate, which is a real problem. And for me, this is what I call data art. Of course, you can use a different kind of visualization, like a line graph. They both use the same data. They communicate the same thing, but it's not the same thing. I'm not saying this one below is better than the other, but I like it more. I think maybe they could be complementary somehow. But going back to this one, for me this is made of three main pieces. One hand you have, of course, a data source, as with any other graph or visualization. Then there's kind of a methodology behind this. So depending on the raw data, you have to aggregate your data and calculate the average per year and so on. And then there is the technique, which is how you put this on a graph to communicate. And in this case, it's something very unique for me. Each bar represents a year. The color represents the temperature. Blue means colder. Red means warmer. I'm explaining something that it's evident, as you can see. And talking about the technique, it's called warming stripes, and it can be used for other types of visualizations. I have to say that this one doesn't like too much to me, but again, it's the same thing. We are here. What happens if we continue emitting as we are, or what could happen if we do something a little bit better? Again, a powerful tool for communicating. And this is what I'm going to talk to you today about data artists, the people behind this kind of stuff. How many of you have heard the term data artist before? Anyone? No one? No one. Great, because I have a definition of what's not a data artist. This is the first result in Google, and basically it says, I'm going to read these two lines. Data artists bridge the gap between business and IT by creating data visualizations that can be quickly understood by business leaders to help accelerate decision making. And if you want to know what I think about this, what? Business? Why? Where is business in this word? And nowhere. There's no business in this word. That could be a business analyst, a data analyst or maybe a data scientist, but this is not a data artist. This is about art. This is about communicating. This is about making unique visualizations. This is not about providing a visualization for someone to take a decision. It's not necessary. And of course, it's not mandatory, as it's said in that definition. So I've been trying to make my own definition of what a data artist is, and for that I've been following a bunch of people in Twitter that most of them labeled as data artists, others as data journalists, others as cartographers, data scientists, etc. You have here a couple of links if you want to know more about them. They constantly share knowledge. Very interesting to learn about that. And well, I made this kind of Venn diagram made by myself. So for me, the 4 skills of a data artist are these ones, can be grouped in these 4. First, of course, they need to know how to work with data, some stats or whatever. They need to know about technology, maybe Python, maybe whatever they use. They need to communicate. This is about expression, your ideas. And they need some artsy skill. This is not about creating line graphs, as we saw before. This is about making unique stuff. And in the intersection of these 4 cycles, I don't know if you see it, someone there is a unicorn, because it does not exist. I mean, it's impossible. Basically, it's very complicated having that role. But the intersection of art with any of the other 3, that could be a good example of data artist. So now you know a little bit more about what I want to talk. And I have a few slides about my journey on trying to become one of these people. I have to say I'm a back-end developer. I have nothing to do with this. So expect the worst from me. So again, I'm going to tell you more or less what I'm doing in my spare time. But there's not just one path. I mean, this is not the path to follow for everyone. And something that I've realized, and that's true that I've been working with data more than 10 years, is that data and visualization is really, really hard. It's really, really, really hard. Really, 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 really. Okay. So yeah, you might have a bunch of tech skills. It doesn't matter. Stats, machine learning, Python, SQL, JavaScript. I use Carto. In my case, I like photography. I like many things. But this is the important ones. These are the important ones. These ones, you can learn Python in 1 month. You can learn Matplotlib. Maybe you don't need to learn it because you have examples and you copy paste. But let me know, how do you copy paste patients? Or how do you go to Stack Overflow and look, hey, I want to have passion for something, or I want to learn to listen? No. This is the hard part of every job. I wanted to highlight it here. I don't have a clue for improving on that, but I wanted to remark it. So how do I learn on my day-to-day? Let me play this. Okay, first, do you know what that man is doing? Do you know what is that piece of whatever? It's marble. It's a pillow made of marble. it doesn't make any sense. It's useless beyond being artistic and so on. But that guy is learning a very complex technique to make marble look fluffy. I mean, the impractical path. I do things that are useless with the only purpose of learning complex techniques for visualizing data. Second, the most important one for me, this is why I forbid talking about business. I do it for fun. And you have here these 5 screens from Mr. Rogers. This guy is drawing a house in a canvas, and he's saying, I'm not very good at it, but it doesn't matter. Indeed, he's very bad. But it's the fun of doing it that's important. It feels good to have made something. So basically, do it, and do it for fun. And the last one, and the rest of my talk is about this movie. Anyone has not seen this movie? Okay, I can spoil it. This guy, Leonardo DiCaprio, represents John Abagnale Jr. It was an imposter. It was a guy that learned how to print out payroll checks and fraud banks all around the world. He was so fucking good that after being chased by the FBI, he ended up working for them. And what I'm doing is to try to be like this guy. But okay, let's stop one moment. So this is a payroll check, and as you can imagine, there's a lot of stuff here, a lot of techniques, a lot of chemical stuff, a lot of manuscript or digits or seals or whatever. There's a bunch of stuff which is quite complicated to replicate. What I'm doing is to more or less the same thing. I'm looking on the internet for visualizations that make me feel something that I see, and I say, okay, this is something unique I haven't seen before. How can I make it? How can I make an exact copy of it with the tools that I know? And I'm not gonna talk about the tools specifically because it's not the important thing. The important thing is it's the process, and the tools is just a tool. Today is Python, tomorrow it can be another thing, or a new library, or another new platform. This is a tweet from Kirk Goldsberry. He's a data artist for ESPN. It's also a data journalist. And he basically takes data from the NBA stats and create visualizations to understand patterns on those statistics. For example, this one is about all the 3-pointers that Steve Curry has scored in all his career. So I look at this one day in Twitter, and I thought, I have to replicate this. This is what I made. It's the same thing, but for Kobe Bryant, my favorite player. And I'm gonna tell you how this works. I'm not gonna show you the code. I'm gonna show you the process, which is the important thing. The NBA provides an API where you can request for shootings from any NBA player. This is all the shootings from Kobe Bryant during all his career. But we want just 3-pointers. And the 3-pointers that he actually scored, which are these ones. As you see, there's a bit of a mess there. So what does Kirk Goldsberry? First symbolizes the points as small dots, even with opacity. That means that when points overlap, like in here, you can have that sense of density compared to other places where it's not happening that. Then, I don't know if you can see it, but he starts adding useless things, like for example, a halo. So it duplicates the layer and applies a different symbology. In this case, it's an halo that provides that look so disco or whatever. Next, if you know that the basket is in this point, you can modify your data, you can analyze it, you can transform it with a spatial query, and you can create lines from any of the points where Kobe scored to the basket. Then you don't have points, you have lines. And there are two important things to remark here. The color ramp. I mean, there's a lot of theory about palettes, color ramps, and so on. For me, this one is quite interesting, from blue to purple, quite 80s. And there's other trick he uses that you can see more or less here, which is called blending. That means whenever many lines overlap, you have more brighter zones. So you can, again, understand where's density happening. Sorry. Then he adds in yellow, which is a color that matches good with the palette. Yellow for the longest scores. And for me, this is the most important thing, and it took me some time to realize he was doing that. He takes the previous layer with the lines and changes the symbology again and applies a blurry effect, which when you combine everything together, it feels like, wow, at least for me. And one last step, and this is my little touch to this, is creating curves for these longest shots, and this is just trigonometry. You calculate the midpoint, you move it a little bit, and then calculate a curve that passes through 3 points. As you see, there's a lot of stuff here. Of course, it's backed by technology, mainly SQL and spatial analysis. The stuff about visualization, like the halos, the blurry effect. And for this specific case, I used Python. You have here, if you are interested, a Jupyter Notebook. You can create this visualization from any NBA player and print it. Another example. This is another guy I personally admire. It's a cartographer, and one day he published this visualization in Twitter, which is a map made only of Swedish roads. I love this kind of maps. Don't tell me why. And I decided to copy it. This one is very simple. There's not much to say about this. You basically go to a web page, download like 1,000 files, city files, for several hours because they don't have an API. You merge them, in the way you best can do it. And well, at the end, what I want to tell about this is that I have titled this technique as correlation for three reasons mainly. This is a map of Sweden made of roads, but you can communicate many different things just seeing the roads. For example, where do you think there's more population density? Anyone wants a sticker? It's clear, okay? So it's a map of roads where you can understand where's people. But where do you think it's colder in Sweden? It's obvious. So again, maybe sometimes you don't have the proper data, but you still can communicate what you need to communicate. I have to say that I made a little trick here, and I forced the gradient so it was more evident. I cheated a little bit. This map is the one that made me wanting to work at Carto. This is from 2014. It's like 5 years ago. Again, it's a map of United States made of rivers, 250,000 rivers. This is my version. From here, I want to highlight a couple of things. I've called it feature engineering for visualization. You know that feature engineering means adding new characteristics, columns, features to your data, usually to get some model, but in this case it's just for visualizing. And here we are extracting two different features. On one hand, to be able to show hierarchy, which means there are rivers that are represented thicker, and those are the ones that have more branches or tributaries or whatever. So you can see you have rivers here more thicker than the others. That's not an information that comes with the original dataset. And then there's the color. So to be able to assign those colors to each segment, you have to calculate the slope of each segment. So one technique for that is to calculate the azimuth, which is the angle from the segment to the north. Doesn't matter. But at the end, what you have is that kind of hill shading. Depending on the part of the map, you can see that rivers cross a mountain and they fall through the shade of the mountain. I have a full Twitter thread explaining about this. Please follow me. And again, I mean, this is a technique that once you know how it works for different data sets, different use cases. That's it. Visualization, feature engineering. I have 5 minutes left because I want you to have time to move and ask. This one, Tanaka style, is about represent in 2 dimensions elevation models with a technique that creates that kind of bevel to each layer. This is quite complicated. This is a lot about spatial processing. So basically, when you work with elevation models, you have a raster file that you can color somehow. But for each pixel, what you have is the altitude of that pixel. And I mean, there are tools that I don't understand what they do. But they are able to calculate what it's called contour lines, which are lines that cover areas with the same altitude. So for example, this area here has the same altitude. So if we want to make a Tanaka map, we have to convert those lines into polygons. Again, this is something that you can do with Python, with GDAL, but it's not important. Important is the process you have to follow. You start with a raster file, you get the lines, you get the polygons. Third step, you get the lines, and you have to symbolize them to look like they are bevel. For this, again, it can be used the azimuth. So you do some feature engineering to know which angle with respect of the north each line has. And in the end, when you stack everything together, you have this kind of stuff where you can see altitude, mountains, etc. You can play a little bit more, change the color palette. In the end, it's a very powerful technique. It's not that common, even in GIS. So I liked it a lot to learn about it. Finally, about animations, this is something quite new nowadays. Animate data. I'm going just to put 3 examples. I have 2 minutes. The easiest stuff is to animate data that has a temporal component because it's obvious. You have like a timeline and you start to draw points whenever they have a date. This is the expansion of Walmart. They started like here. They started to move from here to there. And in the end, they conquered the US. But you can use animations for other types of data that don't have temporal component. For example, this map, which is completely useless. This is the ones I like the most. Cemeteries in the United States, data from OpenStreetMaps. And what I like about this is the animation. It just animates by longitude. Brilliant. Trees. These are the trees of my hometown. We have like 150,000 trees. I mean, pretty nice city. Animation by distance to the center of the city. Quite simple. This is like 3 lines of code. But I mean, it's quite powerful. I like it. There are more. Don't worry. How do I did that? Sponsor time. I work for Carto. This is a super simple vision of our architecture. 3 layers. Spatial database, where you put your data. A bunch of APIs to render maps, to make queries, to enrich data, to import, whatever. And client-side libraries for data scientists based on Python to integrate it with Jupyter notebooks. For developers, we have JavaScript libraries for rendering maps. And they both communicate very well together, so you can join the best of these 2 worlds in your notebooks. This is not very important, I guess. I prefer you to make some questions, but here's an example. Okay, I haven't showed you code. You have it at the end of the talk. There are a bunch of links about this, but more or less the workflow in Python to get that kind of visualizations is: I got my data. It comes from a CSV file, from an URL, from a database. I don't mind. I upload it to Carto, 1 line of code. Then, as you have seen, we have to do many transformations of the data. The data as it comes, most of the times, it's useless for visualization. We use SQL for that, and PostGIS, a lot of spatial functions. You can transform your data the way you want. And once you have the different layers you want to solve, you can create a map that is composed of different layers with a data set and some styling options to define the color, the width, symbol, animation, whatever. So, time for doing La Pelota, and I finish. This is the first law of geography. Everything is related to everything else, but near things are more related than distant things. It's true that I've been working with geographers, because otherwise I wouldn't know this. But when it's about learning, and it's in the process I am right now, I'm trying to learn. I'm not the best on this, but I want to. It's important to have people from who to learn. So I always try to thank these people that I have the chance to work with. They are brilliant. They have probably everything I would like to have. Mamata, Jorge, and Ramiro. And that's it.
Okay. Okay, thank you very much. We have 5 minutes for questions. You can answer with this. So, any questions for the speaker? No questions for the speaker?